So in this question, we have a two-dimensional collision going on with two different nucleus. So we have a nucleus of mass m that is traveling with speed v, and then it collides elastically with a target particle of mass 2m. Afterwards, what happens is that the original particle is scattered at an angle of 90 degrees. So if I call this A and I call this B, after the collision, A is going up, or it could be going up, but it's 90 degrees. Then B will be moving at some other angle, theta. So we are asked at what angle does the target particle move after the collision. So this is a question of conservation of momentum in two different directions. So it's conserved in both the x direction and the y direction. So let's write down the conservation of momentum separately. In the x direction, the initial momentum is MAVA, and afterwards, because A has no x component, it is MB VP prime cosine theta. And in the y direction, initially there is no momentum. Afterwards, it is MA VA prime minus MB VP prime sine theta. So this is conservation of momentum. We also need the conservation of kinetic energy because this is a completely elastic collision. So the conservation of kinetic energy before the collision is half of MAVA squared. So this is just the kinetic energy of particle A. Afterwards, it's kinetic energy of particle A plus kinetic energy of the particle B. So now we want to utilize this relationship. We're giving that the mass MB equals 2 times MA. So if we use MA equals M and MB equals 2M, we can simplify these equations. So this will be simplified into VA equals 2 times V prime cosine theta, and VA prime equals 2 V prime sine theta. And this conservation of kinetic energy becomes VA squared equals VA prime squared plus 2 times VB prime squared. Okay, so we can rearrange these two equations. So right now we have a couple unknowns. We do not know what VA prime is, we do not know what VB prime is, and we do not know what theta is. So we have 3 equations and 3 unknowns. We will be able to solve this question from these 3 equations. But the first step, we need to simplify it. And we usually do that by canceling one of the quantities. So here, because usually we think angle is pretty hard to deal with, so we try to cancel the dependence of theta in these 3 equations. And that can be done because cosine squared theta plus sine squared theta is 1. So VA squared plus VA prime squared is 4 VB prime squared. So by doing this, we got rid of the relationship, the dependence on theta. So we have this, and then we can rearrange the kinetic energy equation into VA squared minus VA prime squared equals 4 VB prime squared. Sorry, this is 2 VB prime squared. Yep, so this is just rearranging this equation. And from this, we can find how VA and VA prime in terms of VB prime. So if we add these equations together, if we add these two equations, what we get is 2VA squared equals 6VB prime squared. Or in other words, VB prime equals VA over square root 3. And we can also find VA prime. It's not asked in part 1, but we can say that if we subtract them, we'll see that 2VA prime squared equals 2VB prime squared. So VA prime is equal to VB prime, which is also VA over square root 3. So now let's go to the 3 part of the question. Part A asks, what is the angle of the target particle after the collision? So that is asking us, what is theta? So to find theta, we have cosine theta equals VA over 2VB prime. So theta equals arc cosine of VA over 2VB prime equals arc cosine of VA over 2VB prime. So that's square root 3 over 2. That is 30 degrees. So this is the angle of what angle does the target move? It moves 30 degrees with respect to the original direction of the incident particle. So part B, what is the final speed of the two particles? We already calculated here. They are both VA prime equals VB prime equals V over square root 3. So in this question, what we originally called VA is officially called V in this question. So I'll start calling it V. So both of them have this velocity of V over square root 3. And the direction, what is the final speeds? It asks for speed, not velocity, so we do not have to specify the direction, but we know that A is moving perpendicular to the original incident direction and B is moving 30 degrees. Last one asks us what fraction of the initial kinetic energy is transferred to the target particle. So that is the kinetic energy of the target over the kinetic energy of the original. Because that is 1/2 of mBVB prime, so the kinetic energy of B after the collision, over the original kinetic energy, which is the kinetic energy of A before the collision. And we already know that mB equals 2ma. I'm ignoring the 1/2 here, over ma. V prime square is V square over 3, and VA square is just V square. So this is 2/3. So this is a fraction of the initial kinetic energy that is transferred to the target particle.